Open 14 Non-Lin1 SimExpert file. Under LBCs, go to the contact group and create contact body parameters. Specific contact parameters can be created here. The parameters must be relevant to your problem. Click OK. Click on the Define Contact Properties icon. Different kinds of contact can be defined here. Geometric properties are created in this tab. Ensure that the glue option is set to zero touch. Physical data can also be specified in the Physical Data tab. As default, the physical data is all defined as 0. Click on the Contact Rigid Body Creation icon. Set motion control to 0 and all velocities and directions. Contact bodies must now be created. Select the Create Contact Body icon. Define the dimension of your problem. Select 3D for the bracket. Define the type of body you want to create. Select Deform. In the drop-down menu, pick Contact Body Parameter 1, which you created earlier. In the Pick Entities box, deselect all filters except the Parts filter. Select the bracket. Click Apply. Now you will create a rigid 3D body of the plate and the bolts. Define the contact body parameter and the rigid contact body. In the Pick Entities box, deselect all filters except the Surface filter. SimExpert will ask for specific surfaces. Select the surfaces where the contact exists. SimExpert's automatic function for detecting contact bodies will recognize unmeshed parts and geometry as rigid bodies. Meshed parts and geometry, or elements with the same properties, are defined as deformable bodies. The next step is creating contact pairs. This defines how the contact bodies are in contact. Click the Create Contact Pair icon. Under Slave, select the contact body associated with the bolts in the drop-down menu. Assign the physical and geometric properties. If no contact parameters or properties were created, SimExpert uses the default settings. Select the masters in the drop-down menu. All the contact bodies in contact with the selected slave must be selected. This is done with all contact bodies. To view the contacts applied to the contact bodies, select all contact groups in the model browser. Right-click, select Properties table. As you can see, if a contact body is selected, it will be highlighted. In this table, the contact properties can still be changed. Create a new Nastran job. Change the solution type to Sol 400, the general nonlinear solver. To set up the solver, right-click on Solver Control, select Properties. Under Output File Properties, change the Nastran DB options to Master Only. Click Apply. Under Contact Separation Parameters, change the separation criterion to stresses. Click Apply. Select the contact set default for the initial contact definition. Click Apply and Close. To change the parameters of the nonlinear solver, right-click on Load Cases and select Properties. Change the Stiffness Update method to ITER, under the iteration for mechanical analysis. For number of iterations before stiffness update, enter 1. Click Apply. Change the number of steps for the nonlinear analysis to 4 increments under stepping control parameters. Click Apply and Close. Right-click on Output Request. Under Nodal Output Requests, select Create Contact Output Request. Check the Suppress Print box and click OK. To attach the created contact to the solver, right-click on LBC container and select Contact Set. Select the contact set default in the drop-down menu. Click OK. Now you can run the solver. Monitor the .fo6 file to see when the solver is done. Open the .fo6 file and search for fatal. If none is found, the job was without error. Search for End of Job to see if the solver is complete. Return to SimExpert. Attach the results. Be sure that the file you're attaching has a .master suffix. Click OK. To view results, select Fringe in the Results group. Under the SC1 group, the different steps of the solution are shown. Select 1. Select Stress Tensor under Result Type and von Mises as the derivation. Click on Update. The stresses acting on the body can now be seen for the specific step. The last step will be the final solution. This tutorial was proudly brought to you by STEC.